I want you to close your eyes. Well, unless you're driving, obviously keep your eyes on the road. But metaphorically, I want you to picture the single most game-changing artifact from ancient Egypt.
Okay.
The one thing that just screams, technological mastery. What pops into your head?
I mean, I can probably guess where most people go with this.
I bet you can.
It's the Great Sphinx, right?
Hmm.
Or the golden death mask of King Tut. Or maybe those massive granite obelisks at Karnak that look like they were cut by laser.
Yeah, that is exactly where my brain goes too. We think big, we think gold, we think monumental.
Naturally.
But what if I told you that the object we are unpacking today, the thing from our sources that might actually rewrite the entire timeline of how Egyptian engineering evolved, is none of those things?
It's really not.
In fact, if you walk past it in a museum, you wouldn't even stop. You'd probably think someone left a piece of, plumbing pipe in the display case by mistake.
Yeah, it's not gold, it's not giant, and it definitely wasn't found in some dramatic, curse-laden tomb opening.
No, it was found in a drawer.
A literal wooden drawer in a museum storage room.
Exactly. So today, we are diving deep into the story of a simple, unassuming, severely corroded piece of metal, a copper drill bit.
Just a little copper tube.
And the reason we are obsessing over this little tube, based on some fascinating recent archaeological papers and reexaminations, is that its mere existence, sitting quietly in that collection, might be the key to debunking one of the biggest myths about how the pyramids were built.
It's a classic case of the most important evidence being the absolute most boring thing to look at.
Right, so let's set the stakes here, because I really don't want people tuning out thinking we're just talking about ancient hardware supplies.
Fair enough.
Why does a drill bit matter? Because preliminary analysis suggests this thing dates to a period well before the Great Pyramids were even a blueprint. We're talking potentially late pre-dynastic or early dynastic Egypt.
And that is the crucial detail. If that dating holds up, it completely challenges the sudden leap theory.
The sudden leap theory. Let's break that down.
So we have this persistent idea that Egyptian technology just sort of exploded out of nowhere, that they went from stacking mud bricks to building the Great Pyramid of Giza in a single generation.
Right, like they just woke up one day and were master stonemasons.
Exactly. But this tool suggests that history doesn't always change with a bang or a golden monument. Sometimes the revolution happens in silence, in a dusty workshop, hundreds of years before the main event.
I want to dig into that silence for a second. Take us into the archives. How does something this important just sit there? I mean, don't museums know what they have?
You'd really be surprised. We have this Hollywood image of archaeology where the discovery always happens out in the field.
Right, the Indiana Jones moment.
You brush away the sand, the sun catches the gold, and you instantly know you've found something world-changing.
But that's not how it usually works.
Not anymore. The reality of modern archaeology is completely different. Museums, especially the big ones in London, Cairo, or Berlin, have millions of objects, literally millions.
Wow.
And a huge percentage of those were excavated back in the late 19th or early 20th century.
Back when they were just shoving things in crates.
Pretty much, yeah. They would excavate a site, ship thousands of minor artifacts back home, catalog them in a giant ledger, and just shove them in a drawer.
Out of sight, out of mind.
Right. And if an object looked functional like a simple tool, it just wasn't a priority. Curators back then wanted statues. They wanted jewelry and sarcophagi.
The flashy stuff?
Exactly. A corroded copper tube. That gets a paper tag with faded ink and gets forgotten for a century.
So it was overlooked simply because it looked too normal?
It was overlooked because it was utilitarian. It's ugly. But recently there has been this major shift in the field called re-examination. Curators and researchers are going back through these old collections with modern eyes and modern questions.
Okay, so they find this ugly copper tube. How do they realize it's special?
Well, when they checked the original excavation records, the provenance of the item, they realized the timeline didn't match the standard narrative we've all been taught.
Okay, hold on. I need to play devil's advocate here for a second.
Go for it.
It's a metal tube in a box. How do they actually know it's from the pre-dynastic period? Couldn't a worker from, 1920 have just dropped a piece of pipe in the crate?
That's a totally fair question. Provenance is everything in this field. In this case, they look at the original excavator's field notes. This object was cataloged as coming from a very specific layer of a specific tomb or site.
And that site had already been dated.
Yes, using things like pottery styles and stratigraphy.
Stratigraphy, that's the layers of dirt, right? Like deeper means older.
Basically, yes. If you find a copper tool right next to a specific type of clay pot that we absolutely know went out of style by 2800 BCE, then the tool has to be from 2800 BCE or earlier.
Makes sense.
They cross-reference the object with the ancient trash found around it, and the trash around this particular drill bit said early dynastic.
Which puts it way before the big names.
Right. We usually focus on the Old Kingdom. Specifically, the Great Pyramid of Giza was built during the reign of Khufu, which is roughly around 2600 BCE.
Khufu, Khafre, Menkar.
That's the Pyramid Age. That's when we see millions of stone blocks and perfectly carved granite sarcophagi.
And the assumption has always been that the technology to cut that insanely hard stone was developed during that time, basically out of sheer necessity.
Yes, the necessity is the mother of invention argument. The idea was that Khufu said, build me a mountain, and the engineers scrambled to invent the tools to actually do it.
But if this drill bit predates Khufu,
It means the sophisticated metal tool usage existed long before the pyramid project ever started.
that completely flips the script. It's like finding out someone had a power drill in their garage for years before they finally decided to build a house.
Exactly, rather than inventing the drill because they were building the house.
Right.
It changes how we view their entire industrial capacity. And industrial really is the right word here. We tend to mysticize the ancient Egyptians, but they were running a massive, highly organized manufacturing operation.
Let's get into the actual mechanics of that operation, because this is where my brain starts to hurt a little bit.
Okay.
We're talking about drilling stone, and not just limestone, which I know is relatively soft, but granite.
Correct. The interior chambers of the Great Pyramid, the sarcophagi, the heavy lintels above the doorways, that's red granite.
Okay, I'm not a geologist, but I know granite is rock hard. I've tried to drill into a concrete wall at my apartment to hang a shelf, and even with a modern steel masonry bit, it's a total nightmare.
Oh, absolutely.
We're saying they did this with copper.
Yes.
But copper is soft. I mean, I can bend a penny with a pair of pliers. How on earth does a soft metal tube cut through one of the hardest rocks on the planet?
This is exactly the engineering puzzle that fuels all those fringe theories. You know, the aliens built the pyramid stuff.
Right, because people can't wrap their heads around the tools.
People look at the Mohs scale of mineral hardness. It's a scale from 1 to 10. Diamond is a 10. Granite usually sits around a 6 or a 7.
And copper.
Copper is a 3.
Okay, so mathematically, the granite should win every time. If I rub a piece of copper against a block of granite, the copper should just grind away into shiny dust.
And if you did that, it would. You are absolutely right. A copper tool by itself cannot cut granite. It is physically impossible.
So how do they do it?
The secret isn't the metal. The copper is just the delivery system. The expert analysis of this artifact, specifically looking at the microscopic wear patterns inside the tube, points to a third party involved in the cutting.
An abrasive.
Yes, an abrasive material.
It's like sandpaper.
Think tougher than that. The sources indicate they used quartz sand, or perhaps even a mineral called corundum.
Okay.
Quartz is a 7 on the Mohs scale. It's just as hard, or sometimes even harder, than the granite they were cutting.
Okay, walk me through the physics here. I'm an ancient Egyptian worker. I have a copper tube. I have a massive block of granite. What exactly do I do?
All right, picture this. You stand the copper tube upright on the rock. You pour a slurry of this loose quartz sand and water right around the cutting edge of the tube.
Okay.
Then you apply weight, a lot of downward weight, sometimes using heavy stones attached to the top, and you start to rotate the tube. They likely used a bow drill mechanism for this.
The bow drill, that's like the thing survivalists use to start fires in the woods, right?
Yeah.
With the string wrapped around a stick.
That is the exact same concept, yes, but on a much larger industrial scale.
Got it.
So as the copper tube spins under that immense pressure, it grabs those loose crystals of hard sand and drags them across the surface of the granite.
Oh, I see.
Because the copper is soft, the sand actually embeds itself right into the metal rim. It temporarily turns that simple copper tube into a sandpaper-tipped hole saw.
So the copper isn't actually doing the cutting.
Not at all.
The sand is doing the cutting. The copper is just, it's just the bus driver.
That is a perfect analogy. The copper is the vehicle, the sand is the passenger doing all the heavy lifting. It's actually remarkably similar to how modern diamond tip drills work today.
Really?
Yeah, we use a soft metal matrix to hold little pieces of industrial diamond. The Egyptians used a copper matrix to hold little pieces of quartz sand.
That is brilliant. But it also sounds incredibly tedious.
Oh, it was grueling work. And we know this because experimental archaeology has actually reconstructed the whole
They
process.
tried it.
Yes. Modern teams have built these exact copper tubes, gathered the quartz sand, and spent days trying to drill into solid granite using ancient methods.
And what happened?
It works. It absolutely works. But it is incredibly slow. We're talking about progressing maybe a few millimeters per hour.
Wow, millimeters.
And the friction creates massive heat generation, so you have to constantly keep adding water and fresh sand to the groove just to keep it going.
That sounds exhausting.
But the most interesting part of those modern experiments isn't just that it works, it's the loss rate.
The loss rate, what do you mean?
This is the underlying economic insight that people often miss. For every inch of granite you manage to cut, you lose a significant amount of your copper tool.
Because the sand is grinding both of them.
Exactly. The sand eats the rock, but it aggressively eats the copper too. Some of these experiments suggest a near one-to-one ratio,
Wait,
meaning you lose an inch of your copper tube for every inch of depth you gain in the stone.
whoa, hold on a second. Think about the sheer size of the Great Pyramid. Think about the size of the King's Chamber and that massive granite sarcophagus inside it.
Right.
If you're losing an inch of copper for every inch of cut you make, that is an insane amount of copper being destroyed.
Exactly. It's staggering. And that brings us right back to why this single early drill bit in the museum drawer is so incredibly important to our understanding.
Because it shows they were already doing this before the pyramids.
Yes. It tells us that long before the pyramids were built, Egypt had already developed a massive supply chain, a state apparatus capable of mining, sourcing, smelting, and refining huge amounts of copper.
Knowing full well they were just going to grind it into dust to shape some rocks.
Precisely. It's not just a technological achievement we're looking at, it's a massive logistical flex.
It's showing off their wealth. It's the ancient state saying, we are so rich and organized that we can afford to destroy precious metals just to build a monument.
Yes, it implies a highly complex trade network and a state economy that could support that kind of extreme waste for the sake of architecture.
I want to circle back to that sudden leap idea we talked about earlier. You mentioned that people love the idea that Egyptian tech just appeared out of thin air.
It's a very persistent myth, mostly because it makes for good television documentaries. We look at the early step pyramid, then the bent pyramid, and then suddenly Giza, and to the untrained eye, it feels like an impossible jump in skill.
Right.
But when you actually look at the physical tools, like our copper drill bit, you start to see the curve.
The learning curve.
The long, painful, multi-generational learning curve. This drill bit is the physical evidence of their experimental phase.
Before they could build Giza, they had to figure out the basics.
Exactly. They had to figure out the right copper alloy. They had to figure out the perfect sand-to-water ratio to make the abrasive slurry work without jamming the drill.
They basically had to fail. Over and over.
Hundreds of times. And we actually find those failures. Archaeologists have found failed stone jars and bowls from the early dynastic period.
Really, like ancient outtakes.
Basically, stone vessels where you can see the drill slipped, or the craftsman made the wall too thin and the whole piece cracked. This drill bit represents that entire era of trial and error.
You know, hearing about the mistakes, it makes them seem so much more human. I think when people ascribe all this to aliens or some lost ancient magic, they're actually insulting the Egyptians.
I agree completely. It totally robs them of their human agency.
It's like saying, you guys couldn't possibly have been smart enough or worked hard enough to figure this out on your own.
Exactly. The reality is much more grounded, but honestly much more impressive. They didn't have lasers. They had curiosity, a basic understanding of physics, and an unbelievable amount of patience.
They were experimental engineers.
Experimental engineers. I love that phrasing. That is exactly what they were.
So taking a step back from the ancient sand and looking at the modern day, this major realization all came from a drawer.
A single drawer.
What does that tell us about the future of archaeology as a field? Are we basically done digging in the desert?
Oh, we'll never be entirely done digging in the sand. There is always more out there. But the new archaeology is definitely shifting its focus indoors.
Because we are realizing that the great museums of the world are basically unmined gold deposits of data.
Yes, it's the backlog. You have to remember, technologies like metallurgical testing, microscopic wear analysis, and advanced carbon dating, none of that existed when these items were first collected 100 years ago.
Tell me a bit more about the wear analysis. You mentioned that earlier with the drill. What can looking at tiny scratches on a copper tube actually tell a modern scientist?
It's basically forensic science. Under a high-powered microscope, a rotary drill leaves very specific marks. It leaves horizontal concentric striations, basically tiny scratches that go entirely around the tube.
Okay.
If the ancient worker was just pounding the metal into the rock like a chisel, the scratch marks would be vertical.
Oh, wow. So you could literally see the spin of the tool.
You can see the spin,
Mm,
and with the right equipment, you can even calculate the rough speed and the amount of downward pressure that was applied based on the depth of those microscopic striations.
that is wild.
It confirms the mechanical method without us needing a time machine to go back and watch them do it.
It's amazing to think that history books aren't printed in permanent ink.
They definitely aren't.
They're digital. They can be updated and rewritten just by looking closer at something we already have.
History is never fixed. It's always a working hypothesis based on our current evidence. When we find a new piece of evidence, even a small, ugly, corroded one, we have to update the hypothesis.
There's something incredibly romantic about that to me. The idea that the next big breakthrough, the thing that fully explains the how of the ancient world, is probably sitting in a cardboard box in a basement in London or Cairo right now.
Just waiting under a pile of old receipts.
Exactly.
It almost certainly is. And as we continue to ask better questions and develop better scientific tools, we'll get much better answers from those forgotten boxes.
So let's bring this all together. We started with a challenge to imagine the greatest, most game-changing Egyptian artifact.
And we usually think of the giant stuff, the gold, the monuments.
But we've ended up with a small, corroded piece of copper tubing.
A tube that proves they were actively mastering the hardest materials on Earth centuries before anyone previously thought they were.
It proves that the pyramids weren't some sudden miracle. They were the graduation project.
That's a fantastic way to put it. The pyramids were the culmination of centuries of dusty, sweaty, copper-grinding experimentation.
You know what stands out to me most in all of this?
What's that?
It's the sheer stubbornness of the whole endeavor. Imagine being the guy who has to drill that granite. You're spinning a heavy bow drill back and forth, the quartz sand is flying everywhere, it's blazing hot, and after an hour of exhausting work, you've gone down maybe 2 millimeters.
And you have to wake up and do it again the next day.
And you just keep going.
That right there is civilization. Real civilization isn't just built on gold and abstract gods. It's built on that physical stubbornness, the willingness of people to solve a problem that seems completely impossible, even if it takes multiple generations to perfect the method.
And the willingness of the society to sacrifice mountains of valuable copper just to achieve it.
Exactly.
So before we wrap up, I want to leave everyone with a final thought to mull over, something that builds on this idea of forgotten artifacts.
Okay, let's hear it.
We've been talking about how this crucial piece of Egyptian history was just sitting in a museum drawer, ignored because it was an ugly utilitarian tool.
Right.
It makes me think about our own era. Think about the early days of the digital revolution.
No, that's an interesting parallel.
The floppy disks, the early hard drives, the messy experimental prototypes that built the internet. A lot of that stuff is sitting in boxes in basements right now, degrading, because it's not pretty to look at.
And future archaeologists are going to have to sift through our junk drawers.
Exactly. But here's the provocative part. Unlike a copper tube, which you can just look at under a microscope, our forgotten tools hold digital data. If they sit in a drawer for a century, will future historians even be able to open our drawers to see the learning curve of our civilization?
That is a terrifying thought, the digital dark age.
Right. It really puts things into perspective.
Yeah.
We rely on physical objects to understand the Egyptians, but our own history might just vanish if the hard drive degrades.
Something to keep you up at night.
Just a little food for thought. But for now, we look at the pyramids and we feel small. They are overwhelming. But this drill bit represents human engineering at its most fundamental level. It's ambitious, it's experimental, and it is beautifully messy.
It connects us to them. Honestly, if you've ever stripped a screw or broken a modern drill bit while trying to fix your back deck, you know exactly how that ancient Egyptian craftsman felt.
So true.
We are still that exact same species, just trying to shape the world around us with whatever tools we have in the box.
And hopefully someone 5,000 years from now will find my broken drill bit in a drawer and think I was a genius.
We can only hope.
Thanks for listening to today's deep dive. It's been a totally fascinating look into the literal tool chest of the ancients.
Always a pleasure to be here.
If you enjoyed this conversation, make sure to follow us. We've got plenty more archives to dig through. Catch you next time.